So welcome to the educational Codeforces round 179. So let us discuss the first question. In the first question, you are given three crystal 1, 2, 3. Let's say 1, 2, 3. And initially all have charge 0. Now your task is to charge all the three crystal to a number x. But and in one operation you can increase the charge of any crystal by any amount. Let's say you can make this say y, uh, where y greater than 0. So you can increase the charge of any crystal. But uh, at any point this condition must hold. That means if you pick any two crystal, let's say this, then half of one crystal has to be less than equal less than equal then less than equal to the other two crystals. So if I pick this crystal, then half of this crystal uh, charge is charge should be less than equal to the charge of this and this crystal. So let's suppose at at any time we have charge 1, 2, 3. Now, if you say the half of 3 is 1.5 and the ground value of this is 1, so this is less than equal both of these. So it is a valid state. Similarly, for half of 2 is 1, which is less than 3 and 1. Okay, and half of 1 is 0, which is less than 2 and 3. So this is a valid state. And now, uh, how can we get to the next valid state and like maximum while a uh, maximizing the health of any crystal. See, if we check, if we increase the health of the lowest crystal, then we can increase it to a level of 2 into like mid value of the three crystal plus 1, because we are considering the ground value, right? So plus 1 will be cancel out. So like 1 into 2, 2 into 2 plus 1 will be 5. So next state will be this. Now if we remove this, now again if you see what is the half of this will be 2, so which is less than equal 2. And again for this again for this 3 by 2 is 1, which is less than all of this. So we can if at any point we have x, y, z, which is a valid state, then we can get to the next stage just by increasing the health of x to 2 into y plus 1. So this will be the best uh, this will be the optimal way to increase the health of the minimum crystal. And we have to make all of them equal to x, right? So we can increase the charge of the minimum crystal to x to we will like continue the operation until health of any crystal is equal to x. When it does, then we simply increase the health of other two crystal to directly x. So if we go through the code, like if you see here, if x equal 1, then we can like initially all are 0, right? So we can make all of all are 1 in 3 number of operations, so answer will be 3. Otherwise we'll create a vector and all values are 0. Then we'll first sort the vector and we'll after sorting the first element will be minimum element, right? So we'll say charge that crystal to like minimum of 2 into middle value plus 1 or x, which is like minimum will charge the crystal to that level and will perform one operation, so will increase the answer by 1. And when this value is equal to x, then we will simply come out of the loop. And the second and third crystal can then directly be charged up to level x. So again I am adding 2 to the answer. So I think this is clear. Like anyone have any doubt? If not, then we will go to the next question. So in this question, we are given a like there is the definition of Fibonacci numbers, and the first value here is 1, then next value is 2, this is given, and the next value the addition of this, and this will go on. Okay, now we have n cubes of size 1, 2, 3, 5, 8, and we are given m empty boxes, and we have to insert all the all these n cube inside these m boxes, and now the and we can insert like in we have to insert the box Fibonacci boxes to the empty boxes while following some rules. The rules are uh, the cube can only be stacked in the box such this the sides of the cubes are parallel to the box. So if this is, I guess, simple. If this is the box, we can only put a Fibonacci box like this. We cannot put a box like this. So I guess this is simple. And second condition is every cube must be placed either on the bottom of the box or on the top of other cubes. So we can place one cube above another such that all part of this block is completely above the other part, like and a larger cube cannot be placed on a top of a smaller cube. So if this is a small cube, we cannot place a large cube above this. Okay, so these are the conditions we have to follow. Now the question asks, you are given the dimensions of m boxes. So the question is, can any box can like m which of these m boxes uh, can store all these n Fibonacci boxes. So we have to print a string of size m. If s of I represents 0, then this means that ith box cannot hold all the n boxes. If this is 1, then ith box can hold all the m boxes. So if you see, uh, let's suppose L, W, and H is the current dimension of the box. Okay, so this is the box, and like I am supposing L is greater than W. Okay, so first box, since we cannot place the larger box block cube above a smaller cube, so first we have to place the larger box. So the size of the larger box is f of n, since there is n box, right? If we place f of n here, right, then there might be some space and there might be some space and there might not be. So let us see for both the cases. See, this is L, right? When this space will be L minus f of n, and this space will be h minus f of n. If this I will call this h dash, and I will call this L dash. If after placing the first box, if we cannot place the this box, then answer will be directly no. If we can place the first box, then we have to check, can we place now uh, can we place the other box here in top. For that, if h dash is greater than equal f of n minus 1, which is the size of the next box, then we can place this box here, right? Then for Fibonacci number, in since f of n minus 2 plus f of n minus 1 equal f of n, so in this space we can place the f of n minus 2 box, right? Then again 3 4 can be placed here, like 3 will be equal to this and 4 will be equal to this. Then again this, if after placing the first block then the second block can be placed here, then the answer will directly true, right? Because this is like the Fibonacci number first, then this will be 2, then this, adding these two will get the third box, and then this will be the next box. So if after placing the first box, if we have the enough space to place the second box in top of this one, then the answer will be always true. Similarly, if after placing this block there is enough space to place this block, that means L dash if greater than equal f of n minus 1. So again we can put this f of n minus 2 box. Then we can of course put n minus 3 here, because adding these two will equal to this, right? Then again n minus 4 will be there. So if we can place first second blocks here, block here or here, then answer will be always yes, otherwise no. So let us go through the code, and we'll do this operation for all m boxes, right? So this I have solved this using recursion. So first I calculated this f of 1, f Fibonacci is till number 10, because this is given in the constraint till 10. Okay, then if this is base case for the recursion, if the height is if the uh, um, dimension of the Fibonacci box is greater than the height, then the answer we cannot like place the block, so answer will be false. If it is greater than any like length or width, then also it will be false, but I have not checked this. If both are less than that, then and we can place the next block in top of this, then the answer will be true. Otherwise I am here uh, doing the same problem for placing n minus 1 box in in a box of less dimension. If L is greater than W, then I am subtracting f of n from L and passing the thing in the regarding the width is same and height is same. This will not increase, only this part will decrease. Same if width is greater, then I am decreasing the width, other part will be same. When n becomes 0, then the answer is true, otherwise it is false. Okay, so I hope this is clear, and in there I ignore this part. I am taking input and checking if this is true, then this is 1, otherwise I am initializing all with 0. So this is the solution for this, and ignore this part. So I hope everyone clear, or anybody have any doubt? If not, then we'll go to the next problem. So in this question you are given an array, and allowed to perform you are allowed to perform one of the this uh, two operation. You are allowed to perform one of the following two actions. So in one operation, that means you can perform this multiple times, but at one operation you are only allowed to perform one of these actions. So what does the first action say? For a1 a2 a3 a1, if we pick an element, let's suppose ai, then we can either make this all values equal to ai, which will cost us I into I minus 1 into ai cost, or we can make these all equal to ai, which will cost us n minus I into ai. uh, so I have to make all the elements equal with minimum cost. So if you see, uh, we only need to perform this operation twice, right? For any ai, first time left hand side will all elements in the left of this will be ai, right? In second operation, all the element right of this element will be ai, right? So we have done the job. Now we just the answer will be ai into how many elements in left hand side plus ai into how many elements in right hand side. So ai if common, then l plus r. Okay. Now our main task is to calculate how many elements are continuous in the array. Let's suppose from ai to aj all elements are k. So then we have to apply the first operation, like making all elements in left hand side this equal to k once. So this will cost us k into I. Then again for how many elements are right side of j, k into like number of elements will be n minus j, I minus 1 if one base indexing. So this is the case. Now we have to calculate this for every k. Okay, we can do this in uh, almost not exactly constant time, just two multiplication operation. So for every array, if I am at I will first check how many AIs are continuous, like AI plus 1. How many these are equal? AI plus 1, AI plus 2. How many are equal? If this interval all are equal, then answer will be n minus this count into value. Left plus right will be number of total number minus this, right? So this is the basic solution. If we go through the code, I am initializing answer to in plus infinity, and I am iterating through the array, and for each I am checking how many elements are equal to this. Like I initialize j with I, then if this is equal, I am increasing g also count. So after this, when the while loop breaks, count will be the number of element which is continuous and equal to ai. So n, then the answer will be n minus count of this into value of ai. And I am like, this is the important part. If you don't do this part, then it will get a time limit exceed error, since you already like go through all the elements. Let's suppose in this case 7 5 5 5 5 10. When I equal 1, 0 is indexing. Then j, initialize j equal to 1, both are equal, increasing count by 1. Then in, again equal to 2, again equal so 3, again equal so 4. Then here not equal, right? J is here, so not equal, so 4. Answer will be how much? N minus something. Then again I am assigning this value as I, because in the for loop I am increasing I, right? So I am initializing I with j minus 1, and this will give us the answer. I hope this is clear. If it is, then yes, will explain the next question.
Yeah, am I audible? Hello, am I audible? Okay. So I'll be discussing question number D and E. So basically, what question number D is saying is that the dean of the college. Basically, there are multiple floors. Okay, there are multiple floors in the college, and at each floor is designated by the digits, except for the first two. For example, a floor is, let's say, 293. Then the floor number is 2, and let's say a number is, let's say, 8181. Then in that case the floor number is 81. Okay, so basically except for the first two digit, we will be considering the other digits, that will be the floor number. Okay, so what our task here is to maximize the number of turns that students have to take, because at each class the students will be changing their classes, right? So we have to make sure that the number of students, basically the number of groups, the number of classes, what I call it, we have to make sure that there are maximum distance between each class switch. For example, there are, let's say, two classes, two groups, and there are, let's say, four classrooms. This. Now we need to make sure that in each class there will be six classes in total. Okay, in a day there are six classes. You have to give it for six classes. The switching takes place such that at each class change, the difference is maximum. The summation of differences is maximum. So, for example, if we take for class number one, I'll take a different example. For example, let's say this. So, as we can see, there are four classes, okay, and there are two groups. So, we'll be outputting two sequence of six classes. So, as you can see, we are alternating here, okay, in order to make sure that the distance between the two classes is maximum. And here also we are doing the same one essentially. And here, since there is only one class and only one group, so we'll just outputting the classes in a serial order. Of course, we cannot have two groups occupying the same class simultaneously. So with this, all these constraints in mind, we have to maximize the amount of distance that the students will have to travel during each class. So basically, we have to kind of maximize the summation of the distances that will be traveled by each of the n classes in n groups of students. And it is given that the class number will be greater than the number of student groups. So of course the greedy approach is to short it, and we make sure that we keep on going from the lowest class to the highest class, right? For example, if there are, let's say, four classes, okay, okay, let's say there are four classes. One class is at the floor, let's say, 1, and another class is at floor 2, and another class is at floor 20, and another class is at, let's say, floor 22. So obviously we will be doing a transition from 1 to 22, then back to 1, then back to 22, then back to 1, then back to 22. Because there's no point from going to 1 to 2 at 1 to 20, right? We have more, we want to maximize the distance, so we'll be taking these 2 points. But let's say there were two groups, okay? The number of groups here is 2. Number of groups is, let's say, 2. So one might say we can do, okay, let's say 2, 20, then 2, then 20, then 2, then 20, right? By this we can maximize also. But the issue here is that this is not the actually the maximum answer. We can maximize it further as well. Because see, as you can see at the very first class, 22 is vacant. So why are we leaving 22 vacant? Can't we just alternate the classes? Right, we can do that, right? For example, 2, 1, 22, 1, 22, 1. And let's say there was another group. Then we will go for 2, 2. Let's say there were a number of class groups, 3. Then we will go for 2, 2, 20, then back to 2, then back to 20, then back to 2, and then ultimately end the day at 20. So this will be the maximum. Why? Why not some arbitrary combination, like, let's say, going from 1 to 20, then 22? Of course, see, one thing is for sure, This will give the maximum distance for just one group. Okay, this is for sure. And see, if we are doing some kind of arbitrary combination, we can't get any higher than this, because see, we are traveling the maximum distances in each of the segments, right? So if we do so let's say an arbitrary combination, let's say one is going from 1 to 20 and two is going from 2 to 22 and then back to 20 or something like that, it will always be either be equal only. At max case, it will be equal to this only. It cannot get higher than that, because basically we are just adding and subtracting only, right? So we are always tracing the maximum distance here, and we are always tracing it here as well. So with that in mind, we can easily say that okay, the we are just going to use two pointer. We are just going to take the maximum value and the minimum value, and then we are going to alternate it for two pair of classes groups, and then same for the middle indices. Of course, you can do some weird combination as well, but this is the most effective one. Okay, I hope the logic part is clear, or should I go on more depth in it? Okay, I'll just go through it just once again, just in case. So let's say there were more classes. So there was another class called 21. Then what will happen? We have already doing this alternation. Instead of going to 20, this will go to 21, and this kind of thing will happen. And let's say there was another group, 4, group 4. Then we'll just take 21, then we'll go to 2, then we'll go to 21, then we'll go to 2, then we'll go to 21, then we'll go to 2. So this will be the alternation if the groups are 4. We cannot have another group. We can have another group as well. If say number groups are 5, then we can also maintain the same classroom here, which will be 20. So 20 to 20, like this, like you can continue. And so on, right? You can just do this as well. There is no issue. Just keep in mind that we have to maximize it, and we also have to make sure that we are not having occupying the same class simultaneously by two groups. So that will be our method. Yeah. So this will be the implementation part. We'll take the input, then we'll sort it, and then we'll just use two indices. And since what is happening here is that at each of the indices, basically each of the groups have six classes, right, in total in a day. So we'll be outputting them simultaneously only, like this. And then if it is not odd, then we'll having two two outputs in each of the iterations. So basically I'm doing it in a pair of two, so that I can do the alternation also, which I've shown here. This alternation I'm talking about. Okay, this alternation. But say there was only sorry, let's say there was only one class. In that case, of course, if I don't have this if condition, it will output two classes, right? Two groups. There was only one group. So we also need to make sure of that, that at the very last indice, we if it is odd, then we output only one of this, and this part here gets kind of omitted. Yeah, that is the basic implementation of this. I hope the solution is clear. It's clear. Hello, am I audible? Okay, let's move on to question number E. So what question number E basically is stating that you will be given a string which will only have ABC, the first three integers of an alphabet, and Latin alphabet, and you will be given Q queries, You can choose any arbitrary query, but of course in order. And what you have to do is that you have to make the string lexicographically smallest. What is lexicographically smallest? Basically, if a is lexicographically smaller than b, then if a is a prefix of b, which is not that much relevant in this case, in this question. And apart from it, the second condition is that the first indice where a and b differ from the starting, the value of a must be lower than value of b. For example, at that point b has b, so a must have a, something like that. So yeah, so in each query what you can do is that you will be given in two characters x and y, and what you have to do is that you have two options: either do nothing, or you can choose to convert one x to one y, only one of the x to y. This part actually made me kind of confused in the question during the time I was solving, but okay. So we will given n is the basically number of test cases is 10 to the power 3, and the number of queries is 2 into 10 to the power 5, and n is also 2 into 10 to the power 5. So you have to make it lexicographically smallest. And you have also given an additional constraint of n will not exceed 2 into 10 to the power 5, the summation of n over all the test cases. And same goes for q. So obviously a big O of n solution or n log n solution is valid here. So that is what we'll be doing here. Now you may notice one thing is that how many types of conversion are possible here. One is A to B. Let me just write it down. One is A to B. One is A to C. One is B to A. One is B to C. One is C to A, and one is C to B. Right. Remember, this is a one-way conversion. Like you cannot convert y to x, a character y to x. You can only convert one x to one to a y. Otherwise, you cannot. You can do nothing. Also, it's up to you whether you want to utilize it or you don't want to utilize that query. So you may notice one thing. If let's say what will be our target will be to, of course we cannot reduce the length of the string, right? So the prefix question goes out of the box only. And since we have to minimize it, so obviously we will be targeting the very first index. We will try to make it as small as possible, right? For example, if it is like something like bb aa bb cc a, so our target will be to convert this b to a, right? Even if we are somehow able to convert this entire thing into a, after the b part actually. Up to this, if we are able to convert this entire thing also into a, still if we are only able to convert this into a, the this part will be actually smaller, right? This, just write it down. This will actually be smaller than this thing, right? This will be smaller than this thing because the very first index where they differ is having a in this side. So this will actually be smaller than this. So our target will be to, irrespective of whatever happens to the latter characters, our target will be to minimize this. So in order to do this, what we will do is, of course, you can see one thing: we will never be converting A to B, right? Why will we be upgrading to higher level of characters, right? A is the smallest we can achieve. If it is already A, why will we convert it? There's literally no point in it. So we can actually get rid of these two operations. I hope it is clear. And then from B to A, conversion is okay. Now you may ask, why B to C? Again, we are going to a higher level. Of course we are. But let's say number of, if we cannot do B to A, but somehow we are able to convert this B to C, then C to A, then it will be beneficial. And same case for C to B to B to A, right? So that is what we will be making sure here. So this four operations will always be valid for us, and this four operations is the only four operations that we will be doing. We will never be converting an A to B or A to C. So how do we do it? So at we can, of course, one thing, do make sure that when you are following this instruction, right? Um, B to C and then C to A. The query, because since we are doing it linearly, right, query base, we will first be converted to B to C, then C to A. So of course the query for B to C should be before B to A. Sorry, C to A. Otherwise, how can you perform it? Right, you cannot perform it. So we will be making sure that B to C, then C to A. So B to C should be before C to A in the query order. Okay, and same thing for C to C to B and then B to A. So that is basically the intuition. So what we will be first checking is, can we first, if there is a, we will ignore it. There is no point to discuss about A, right? If let's say there is a at the very front, there's no point to discuss. It is already the smallest. Why would we bother about it? We will keep it A only, okay? But let's say when we encounter B, of course our target will be to convert it into A. So first we will check, can we convert B to A directly? If yes, then yes, we will directly convert it. If no, then we will check, can I convert B to C, then C to A? If that is true, then also we can convert it. Now similarly we'll doing here, let's say we are able to achieve it up here. After that, when we encounter our first C, so what will happen here is that C, we will check, can we convert C to A? Let's say we are unable to do that. Can we convert C to B and then B to A? Let's say we are not even able to do that. But we will also need to check for B to C to B, because B is smaller than C. So we will, if it is possible, then we will convert C to B also. Something like that, okay? So this is basically the intuition behind. I'll explain it further, by going through in code also. So, okay. So basically, I've used a map here to store the transitions that are happening. I've stored taken the string as an input and query, and I've used a pair, basically the transition that will be happening, and the indice where it will happen. Because remember, we need to keep a track of at which indice we can do transition. Okay. So if it is A, we can just ignore it. Otherwise, A to B transition we can do at index some. Okay. Uh, you may notice one thing is that, for example, if there is A to B and then there is B to A, let's say there are two queries only. I am marking this query as 0, which is actually wrong, because this query is actually not 0 rank. Its rank is first. The rank, it is 0 rank will be of this guy, but it doesn't matter in this case. Why does it not matter? Because see, we are already ignoring it, and it will still follow the relative order, so it won't matter to us. Okay, I just explained it just in case anyone is having confusion regarding that. And then we have stored it. Now first we will be checking for B. Okay, is this B? Okay, if it is B, then we will check, do we have any index, any operation from B to A? If yes, then we'll perform it, right? And why we are only deleting the beginning part, you may ask, right? Why the beginning part? Why not the end? See, if we delete the beginning part, it will be better for us, because end part can be utilized later on, right? When we are doing C to B and then B to A, then just in case, let's say C to B is in a very last position, but there is a B to A which is even further than that. So of course we would want to keep it for this guy, right? And we can get our work done anyhow, right? In this case, so it doesn't really matter here. So we'll be just taking the first index here. So we can always leverage the last index thing. Now, if that is not possible, then what can we do? We can do one thing, which is we can convert B to C, then C to A. That is what basically I've done. I checked using this the first index that B to C is possible. Why first index again? Because C, we want to make sure that C to A is after B to C. So how can we achieve that? To make sure we will make sure that B to C is at the very first index, right? The earlier it is, the more higher chance of me having a query from C to A, right? And then we have used the upper bound. Actually, technically, you should use a lower bound here. Why a lower bound? Because see, what upper bound gives you is the first index the index where the this index is smaller than this index, the value the index that it will give. Okay, you see the value that this guy stores should be just smaller than the value this guy stores. But why didn't it give any issue? Because see, here index cannot be same, right? That's why it didn't give any issue. Otherwise it will would have given issue. So if equal to matters to you, like even if index like index is, if even that is the case and it's okay with you, then you should use a lower bound. But since it doesn't really matter here, as all the indexes are pairwise distinct or unique, whatever you call it, so yeah, we'll do that. So if it is not end, because basically if this index doesn't exist as an index where b2c c2a doesn't exist, which is after index idx, then it turns the end of the set. So if that is not the case, then what we will do is we'll store this and we will erase the two instances because we have already used those two queries. Otherwise, for we'll go for C and then check can we convert C to A. Otherwise, if we can, then we are happy, right? We are able to convert C to A. If not, then we will check can I convert C to B then B to A, and then the same procedure here which I have explained for our we call it B to C to C to A. But there is a else if also, because remember that we still need to convert C to B if we are unable to convert it. So this is actually the part where I got the wrong answer. Basically, I had added here C to A, C to B, but I forgot to add it here. Why is this giving issue? For example, let's say both of them are not empty, okay, and it goes inside this else if loop, and then we find that okay, both of them do exist, but C to B is after B to A, which of course doesn't allow us to do the desired operation. So that's why what will happen is it will try to execute this, and since this will fall. So the inside block will never be executed, and we won't be having the B that we could have had earlier. So that's why I've added it. Else if this is possible, then we'll do it. Otherwise, uh, we can check it outside also, just in case we can perform C2B, but B2A is just not possible only entirely. There is no B2A, and we can do it like this also. Then we'll output the string. Okay. I hope the implementation and the logic part is clear. Okay. Thank you.